we are a team number 34-3. This is the power utility management using smart meter AMI we have built for Texas Instrument Analog Design Contest 2012-13. In India, major problem is the power crisis. To overcome this problem, we have formulated a solution. That is, instead of shutting down the entire power supply in a different areas in a shifting basis, we can provide a power supply to all the areas with load restriction. That is, usage of only low power devices. We discuss about the components used in this project. First of all, this is transformer 15015. The reason why I have chosen this one is we need both plus 12 volt and minus 12 volt for op-amp that we have used in here. That is OP07 and LM7 for one operational amplifier. And next is these are the rectifier. This is to rectify the AC voltage, and next these three are the voltage regulator ICs. And first one is 5 volt voltage regulator. That is this is simply used to provide power supply to PIC and other ICs. And next two are 12 volt voltage regulator, that is used to provide a plus 12 volt and a minus 12 volt. And this is a trim part which is used to set a reference voltage for measuring the input voltage, that is load voltage. And if we see about this transformer, this is this transformer is of ratio 0 to 6 volt. The main concept of why we are using this transformer is that it is used to measure the load voltage that we are consuming, and it will be connected to a resistor. That is this voltage will be dropped down by a resistor, and next is given as a input to it is given to a potential divider, and then it is passed to the first operational amplifier, that is OP07. And the function of this op amp is to invert the power, that is output voltage. And next is passed on to LM741, and this operational amplifier is just amplify the voltage signal. And this op amp is dual. This IC contains a dual operational amplifier. That is here this IC we are using for a current amplifier. And next, if we see about this current transformer, the reason why I have used this is to measure the current that is being consumed. And this is we have manually winded this current transformer, and this output is sent to the operational amplifier, that is dual the IC with the dual operational amplifier. And this is amplified, and it is fed as analog input to the PIC controller. This is the controller we have used in this project, PIC 16F83 series. And these two, the input of this voltage and current are given to us analog input pins 1 and 2. And if we see about this transmitter module is to transfer the data, that is data such as power consumed and request for special cases. For this purpose we will be using this transmitter. And we have provided 2 push buttons for the consumers. That is first push button is to, if you push this button, the user will be knowing about the power that is being consumed for a month. And next button is for dual purpose. That is, one is for to activate the load back in case of overload, and next is for request for a full load. That is, if the user is getting a partial load, if he wants to get a full load, then he can just send request to this button. And now let's see about the master node. This is the master node, that is the station from where we can set the data, that is such as power, partial power load outage, and such as other things. And this is max 232 IC. This is nothing but TTL conversion of TTL logic. That is this used to communicate with the PC using RS232 port. And this is also a transceiver that as like used in the server secondary node. And if we see about the ICs that we have used, we have used three of Texas manufactured ICs. That is one is CC2500 transceiver module. This is manufactured by Texas Instruments. And next thing is operational amplifier OP07 and LM741. And next one is operational amplifier LM1458. And these 3 ICs are also manufactured by Texas Instruments. working of this project. As I power on this circuit, as you already see that it shows a smart meter, and below this is unit that is being consumed by this circuit. And as I already show about the functionality of this two push buttons, when I press the first push button, it shows the power that is being that is consumed by this node. And next button is for a special request. I will tell it later. And let's see about how we can set the partial output to this node. And this is the form that we have designed in order to transmit to this secondary node. And in this first column, it denotes that the power consumed, that is the power that is consumed at that node will be sent to this server. And next is load that we can set to that server secondary node. For example, assume that we are setting this for 100 watt, and once I enter this and click set, and next. Now let us, for example, let us consider two devices. That is, one is a CFL lamp, which is of 3 watts power supply, and next is a table fan, that is greater than 100 watts. Now let us check how the circuit behaves if I plug into this output. Now, as we seen that this is a low power device, it simply glows and it doesn't show any overload. It doesn't show any of the overload marks. And let us see how it behaves if we plug in the table fan. Once I plug in this into the socket, it shows overload, and relay gets turned off, and the fan will be turned off. And in order to regain the power, we have to click on this request send button. Before that, we have to remove this socket. And next, we have to click on this request send button. And next, I have to describe about special case. That is, if the user want to use the entire load rather than the partial outage, we have to just click on this request send button. And once I press this button, as you see in the server node, it will be displayed that requested for full load condition. Once I get this indication, I have to set the manually the full load condition as like some 1000 watts, and to set. Now the user will be able to use all kinds of power supply.